All right, let's jump right in. So you've done it. You've spent months, maybe even longer, building that perfect machine learning model. You've launched it, it's out in the wild, and it's working like a charm. But here's the thing. The job isn't over, not even close. The real challenge is keeping that model sharp and relevant in a world that, just refuses to stand still. So today we're going to break down the two main strategies for doing exactly that.
And this is the question that probably keeps a lot of engineers up at night. You had a model hitting, say, 95% accuracy on day one, but now, a few months down the road, its performance is just tanking. So what happened? It's a super common, high-stakes problem, and let me tell you, it's not because you messed up at the start.
While the culprit actually has a name, it's called model drift. That's a technical term for when a model's predictive power just sort of decays over time. You can think of it like a slow, silent erosion of its performance, where this once amazing model slowly but surely becomes a liability.
So, here's the crucial point. Your model was trained on a snapshot of the past, right? But the real world moves on. Customer behavior changes, market trends shift, new products get launched. The data you're feeding the model today is fundamentally different from the data it was trained on. And if your model doesn't adapt to that new reality, it's going to become obsolete. This is why retraining isn't just a nice to have. It is absolutely essential.
So how in the world do we fight this drift? Well, there are two main philosophies, two really distinct patterns for keeping your models fresh and effective. Let's break them down.
First up, we've got batch training. The best way to think about this is like studying for a big final exam. You gather up all your notes over a set period, let's say a whole week of customer data, and then you have this massive deep dive study session where the model relearns everything from scratch on this new, bigger data set. This is just perfect for problems like, say, predicting which customers might churn next month. You don't need a prediction that's up to the second for that, so a big, comprehensive weekly refresh is both super powerful and pretty efficient.
And on the complete other end of the spectrum, we have online training. Now, this is more like learning a little something from every single new conversation you have. As each new piece of data comes in, like a single credit card swipe or a click on a product, the model makes a tiny incremental update to itself. This is absolutely critical for things like real-time fraud detection. You can't wait until midnight to find out a transaction from this morning was a scam. The model has to learn and adapt in milliseconds.
So we have our two main contenders, the scheduled deep study approach versus the continuous on-the-fly learner. And I want to be super clear here. Neither one is just flat out better than the other. The right choice depends completely on what you're trying to do. So let's put them head to head.
We're going to compare them across three really critical dimensions that every single engineering team has to think about. How much is this going to cost? How hard is it to build and manage? And of course, how up-to-date is the model going to be? Okay, this slide really lays out the whole story. Let's start with compute cost. Batch training, it can be expensive, but it's predictable. You're spinning up a ton of resources, but it's on a set schedule, like every Sunday night at 2 a.m. Online training uses way smaller resources for each little update, but it's running all the time, which can definitely add up. Now, what about operational complexity? Batch is generally simpler. It's a workflow we understand pretty well. Online training, on the other hand, is much, much more complex. You need a pretty sophisticated streaming infrastructure to handle all that data in real time. And finally, model freshness. This is where you see the real difference. With online, your model is always just seconds old, which again is essential for that fraud detection system. With batch, your customer churn model might be a few days out of date, but you know what? That's a totally acceptable trade-off for how much simpler and more reliable it is to run.
Picking a pattern is one thing, but actually implementing it so it doesn't break, that's a whole other ballgame. To do this right, you need a solid MLOps foundation. This is basically the engineering toolkit that turns these ideas into a real production-ready system that you can actually trust not to fall over.
And this really illustrates the core workflow you need. First, you've got to orchestrate your pipeline. This means using tools to automate the entire process, end to end, so models get retrained and deployed without anyone having to manually click a button. Second, you have to version everything, and I don't just mean your code. I mean the dataset you trained on and the model file itself. This gives you a perfect audit trail so you can always reproduce a result or figure out what went wrong. And third, and this one is so important, you must plan your rollback strategy. Because someday, a new model you deploy is going to perform badly. It just will. And when it does, you need an automated, immediate way to just flip a switch and go back to the last good version. It's your safety net. So after all that, which path do you actually take? Well,
The decision isn't just about the coolest technology. It's about your team's maturity and what your product actually needs. I like to frame this with a simple crawl, walk, run approach.
Here it is, maybe the most important piece of advice in this whole thing. Do not over-engineer. For the vast majority of cases out there, starting with a simple, nightly batch retraining job is the crawl phase. It is reliable, it's understandable, and it delivers huge value without all the headaches of a complex, real-time system. You should only move to the walk or run phases with online training when you have a crystal clear business reason that justifies the extra complexity and you have the engineering team to support it.
So to help you figure out what to do, here are the exact questions to bring to your next team meeting. First, how fast does your model actually get stale? Are we talking hours or weeks? Next, what's our budget really look like for compute costs? Can we afford to have something running 24/7? And what's our team's tolerance for operational complexity? And maybe most importantly, how critical is it really to have a model that's updated to the second? Does the business actually lose money if it's a day old? You got to be really honest about those answers. And all of this really leaves us with one final thought. In the world of production machine learning, it can be so tempting to chase the most complex, cutting-edge solution, but that can be a trap. The true goal is to build a system that is robust, predictable, and consistently delivers value. So remember, the goal isn't the most advanced model, but the most reliable one.